Hello there, this is KSteve of KStevMath, and I picked up a resource to use for one of my classes, and I thought that I would just go ahead and do an unboxing video of it so that if you as a math teacher or parent are thinking about getting something similar, you'll be able to decide maybe whether or not this is something you want to get. So I am unboxing some folding geometric shapes. Alright, here we go. I think this is actually going to be backwards unless I manage to switch it around. But in my pre-algebra class, we are talking about surface area. I'm just now opening this. I took the cellophane off, and that was it. We're talking about surface area, and so I wanted some figures that I could show, right? That we could talk about what is this shape, and the naming conventions of shapes and things like that. Unfortunately, I didn't get these in time for my class because I'm a procrastinator, but I thought that for the video I make of it, I will have these to show off, so that's nice. So I noticed these are actually taped. So there's two reasons that I went for this particular thing, is because there's lots of options actually out there if you're looking for solids to use with your, oh, I'm going the wrong way, to use with your kiddos. And the cool thing about this is that once I get some scissors and open this up, they fold out into what's called nets. So that, because we're talking about surface area, is going to be helpful because it helps you visualize what are the shapes that make up each of the sides. I'm pretty sure I've seen these before in classrooms. I just haven't had a set myself before. So I got these off of Amazon, and I will put a link in the description. And if you, I don't know that scissors were actually a great way to go because I want to actually peel these off, so that's silly. If you would like to, if you decide, oh, I'm interested in this, this looks like a great set of shapes, you can click that link in the description. It is an affiliate link, so if you did that and bought something, it does supposedly make me money, but I have yet to see that actually really happen, so who knows. Okay, so move these to the side a little bit here so we can, oh, not this one. We can focus on, here we've got a rectangular prism. Or, I don't know, we might actually even call this a square prism. I just realized. So we have this lid kind of thing going on. It comes off pretty easily. And then inside is the net, which, like I said, that's what I wanted for us to be able to visualize surface area and also to be able to visualize nets, right? So once it's folded out like this, right, you can talk about, you know, what are the shapes that we're making this up on the outside. And you can talk about how do I find the area of each, and then add those areas together to get surface area. Then when you're done, fold it back up and put it in. It also helps, I think some students are pretty good naturally at being able to visualize these sorts of shapes and nets and things like that. There's a spatial reasoning component to this that some kids just really get without much effort, but not all of them will, and so this can help kids practice visualizing, okay, if I fold the sides up, what shape is this going to end up being? So each of these have at least 2 pieces of tape, by the way. And maybe may go back to take off the extra stickiness as well, because it's leaving a little residue. So I'm imagining that at some point I'll also talk with my kids about volumes. These shapes would also be great for volumes. They would be great for just talking about naming 3-dimensional shapes. This is a cube, right, because it looks like these are all squares. And so then you take it out and flatten it out, and we've got ourselves a net, right? So you can visualize the squares that are made up, or that make up this cube. There we go. I can see how these lids may not stay on very well. So definitely not something, well, I probably will let my 3-year-old play with them, but not something I'd let him play with just by himself. Because I feel like the lids would get kind of misplaced or something. We started off with surface area pretty simply, so the square prism and The cube will be helpful. This triangular prism will be helpful. I think it's neat to have something like this hexagonal prism, more to talk about the naming, because actually I referenced an octagonal prism in class, even though I didn't have one to actually show, but this would have been great to be like, here's how we name it. Here's what it means to have a prism, right? You have the same shape on either side, and then all around you have rectangles that are, you know, making those sides come together. Also, since it's see-through, it would be very easy just to lose track of where the lid is. So see, got ourselves a net right there. So, voila. Looks good. So, the other thing that we are focused on is pyramids. So that's the other ones that I would look at. And again, just the naming convention of this, right, is that one of these is a square pyramid, one of these is a triangular pyramid. It would be even better if they had included a hexagonal pyramid or something like that, but that's even less likely for us to see, right? I feel like than the hexagonal prism would have been. So I can't blame them for not putting it in. So the other cool thing you can do, by the way, if you're doing a section like this, is print out on cardstock nets and have your kids cut them out and glue them together. So the students I have are a range of ages, so they'd probably be like, you know, 7th grade to 7th and 8th grade mostly, right? And so I actually brought like blunt tip scissors and glue sticks, and so there was talk that they felt like they were back in kindergarten, but I think they actually secretly enjoyed it. And then the glue sticks didn't work super well, so like we folded our nets and tried to glue them, and then they still came apart. So, but I think it was neat for them to be able to visualize. I think it's neat to be able to actually look at and see in your hands, like, this is a square on bottom, and then it has 4 triangles, and to actually look and be like, oh yeah, those 4 triangles, they would be the same size. So we only have to find the area of one of them, and then times that by 4, and then add the square on bottom to get surface area. So if you don't want to get, you know, something like this, I spent a couple bucks on Teachers Pay Teachers to get a set of nets because I didn't want to have to do it myself or make them myself. And so I can include a link to that as well in the description if I remember. Oh, there's an activity guide with this over here. So that's nice. The other thing that's nice about having visuals like this is, especially for a triangular pyramid, I find it hard to visualize that on paper, and especially to draw it myself on paper or on a board. So I think it's really helpful. There's something weird on this one. The corners have like reinforced edges or something. Maybe they thought it was going to be too pokey, so they have like rounded edges. I don't know if you can see that. So it kind of threw me off for a second. But here's our triangular pyramid. Ugh. So I was saying something before I got distracted. And is this not really completely triangular? It didn't look like it went in the other way. I guess not that it's not triangular. I think it's not quite an equilateral triangle, maybe is the gist of it. And then we are not yet doing cylinders or cones, but this would be super helpful. And again, not just for surface area, but talking about volume. I actually was helping somebody in calculus recently and realizing that, like, I don't know if we always do a good enough job in the younger grades of talking about why the formulas are what they are for volume, especially because the volume for a cylinder is not so different from finding volume of a cube, right? For a cube, the volume would be, I guess, side cubed. So let's pretend it's a rectangular prism instead. So we do length times width times height, right? To find the volume of something like this. Well, we'd do that for this if we could find length and width. but it's more complicated. And so when we realize length times width for this is the area of the base, then we're timesing it by the height, we can make the connection here that, okay, we need the area of the base, which is a circle, pi r squared. We need to times that by the height. And then we end up, and this is also true with the relationship between pyramids and, I think, pyramids and rectangular prisms, like it is for cones and cylinders. There's a relationship between their volumes, that if this will fit inside of this, then there's this relationship we have, right, of the volume is 1/3 of the volume of this cylinder. Can I fit this in so we can see? Kind of. Probably if I actually took out the net and did it, it would work better. We can kind of visualize, like, how much is the missing space compared to the space that's filled in and things like that. So I think since I am teaching some younger grades than I once did, I think that I will get quite a bit of use out of these, and also at some point talking with my son about shapes. I'm sure that will be helpful. So hey, thanks for watching. Hopefully this was helpful to you. Definitely anytime, right, you buy something off of the internet, there's always that whole, like, is this going to be worth it? Is it helpful? I think these seem okay sturdiness wise. So it's not like I would just hand these out to the most rambunctious of children and expect them to stay in one piece. So I'd say they're like medium as far as like how tough they seem. They're a bit small if what you're doing is a whole class demonstration, right? But I do think that it's better than not having anything, right? And yeah, I think it's overall pretty good. So thanks so much for watching. Feel free to like the video if you want to, no pressure, and subscribe if you haven't already, and see you in another video.